Hi, everybody. I'm Maureen Sala-Dombrowski, the CSP-AIMS Program Manager.
And I'm Lauren Curry, one of the CSP-AIMS facilitators. I am a computer science teacher in Las Cruces at Las Cruces High School.
And hi, I'm Elisa Cundiff. I am also a computer science teacher at Las Cruces High School and fortunate to be part of the CSP-AIMS project. Go ahead.
My name is Eric Allatta, and I'm a computer science teacher in New York City at a small school that has 4 years of computer science. I've been a part of the Computer Science Principles pilot group for the past 3 years, and I've tried out some different curricula and kind of watched the course as it's developed and as we get ready for the launch in 2016.
Hi, Eric. Thank you so much for joining us tonight. We're going to just kind of start with our first question for you tonight. How do you see modeling and simulation fitting into a computer science principles course?
One of the big threads in the computer science principles framework is thinking about computing innovations in terms of data, and that's one of the pillars of one of the 7 big ideas, one of the pillars of the computer science principles framework. I think that modeling and simulation are an essential way to interact with that core idea of data. There are really 2 ways to interpret the data idea. So it's the way that algorithms represent data and use data to in the algorithms, and the way that data impacts our lives, how data is analyzed on a very large scale, and how it impacts policy decisions, and how it impacts the way that we interact with technology. So we want to talk. I think modeling and simulation are thinking about the algorithms of computing and the impact of data or the analysis of data. So you're kind of like you're showing the data, and you're showing how ways to visualize the data, and you're also showing how an algorithm is going to interact with that data, how it's going to consume and produce some new information.
Fantastic. Thank you. And kind of on that same line of thought, how do you envision a modeling and simulation project, such as the ones we're doing in NetLogo, that they could be used to meet and create the performance tasks?
The performance tasks. So that there are 2 performance tasks. The first performance task, the create performance task, is an artifact creating task. It's done in a programming language, and it is done collaboratively, but has very open-ended requirements. So really any algorithmic environment where a student has to write the algorithm to generate some kind of output can be used in that task. And what you're doing in NetLogo, fits perfectly. At the same time, I kind of the way I was talking about my 2 interpretations of data is that the explore performance task, the second performance task, where students have to pick a computing innovation, I think that potentially the modeling and simulation could be a lens for the computing innovation, or maybe the modeling and simulation could be considered a computing innovation in itself. If you have students look at particular models that have been done and have had significant impact on populations. Really the open-endedness of CS principles, which I'd like to talk more about this, but generally speaking, the open-endedness just allows for so many possibilities.
Thank you. You actually answered our next question, which pertained to modeling and simulation examples serving as the basis for exploring the explore performance task. So we're going to jump right to the next one. How do you prepare students for the written portion of the performance task?
I've done a particular approach. But I've also heard just dozens of different approaches that are really population dependent. So depending on who your students are and what preparation they come in with, I think certain pedagogy is more or less appropriate. So let me talk a little bit about my population and some of the techniques that I've used. I'm in an urban environment, and my students come in without any filtering mechanism. They don't take a test to get accepted. They come from a very wide pool of students from all across New York City. They did indicate that they wanted to go to my school, but other than that, they didn't have to meet any certain requirements, which really gives me a pretty wide range of student. The students come in on average 2 years below our local benchmarks for literacy and math. The students, in order to produce meaningful work, need a good amount of scaffolding and a good amount of practice explicitly connecting the requirements of the task and the rubric to their own work. I have broken up programming-related topics and writing-related topics and address them separately in my course so that I can really focus on writing skills. I work heavily with the English department so that I'm using the same pedagogy. So that, for example, what I mean by using the same pedagogy is annotation. Using the same annotation, underlining main ideas, circling evidence, and then writing directly from annotation into sentences using using the tied paragraph format. I find that if you use the same the same exact pedagogy, you can leverage skills, but students won't necessarily call up skills they're developing in other classes unless you help them build those bridges explicitly. On a typical day during the writing portion of the course, students will read an article together. They will discuss the article in a whole group setting. Sometimes we've used a Socratic seminar or a fishbowl, different, or we might jigsaw it. I mean, I literally use the techniques that I'm learning from my English teachers to digest a text. So I'll typically pick a computing innovation, which could, for example, flying drone technology. And then I'll find an article about flying drone technology. For example, I found an article where drug dealers were using flying drones to steal from each other, and I thought that was really interesting. So the flying drones have infrared sensors, and they can find fields of marijuana, which is just that is not an impact of technology that I had thought about. So on a given day, we'll find a computing innovation and a current event article about it. We will read that article and annotate the article with reference to a row on the rubric. So a row on the rubric might be, for example, let me pull it up, might be finding a population and discussing the impact of that on that population. So it would just be annotating the article for keywords that indicate which population of people has been affected by the innovation. Then we will write a paragraph using the rubric. After discussing it, I might show them a model of that paragraph, and then we'll have the students share out. Then the students will research their own article on the same technology and then perform the same analysis on their own. So that's a pretty heavily structured approach to writing in the Explore performance task that I've used. I heavily use Google add-ons for this type of writing. I use the Doctopus add-on to share out documents. I use the Gubrick web app to give students feedback, and I use the performance tasks rubrics on a daily basis to give them feedback. And I also make my own rubrics that I think that you can, if you take any one row of the performance task rubric, you can break it down into a couple of sub skills that we might use on a daily basis. So like, for example, one of the rows is analyze data and information, and you need to identify data that's used in the computing innovation and describe how the computing innovation uses the data as input and output. So just talking about data takes quite a lot of time. You want to really think about what information the computing innovation is using. If it's wearable technology, it might be data from the human being, like the heartbeat of the human being or the number of steps from that human being, and then thinking of the innovation as a computer program that's taking that data as an input, doing some computation on that data, and returning that computed data as new information. Students need to be able to describe that, and they need to be able to describe that in 100 words or less for each of the prompts. That requirement puts a pretty heavy demand on very pithy technical writing. And there, I think there's a departure from the English department, where the English department might do creative writing or very descriptive writing to get into a text, to explore the motivations of a character or a theme, where we need the students to be very concise. So I think that what this really does mean is we need to get better at developing our own pedagogy for writing. That's something that I'm just starting to do, something that I really want to focus on for next year. And at my most ambitious, I would like us to focus on using the same kind of approach to writing programs as we do to writing our analysis. So if a program has an input and an output, I want students to think about it in that way. And if a program has test cases, I want the students to think of test cases as evidence statements, and just find some way to make. I want there to be a parallel between the writing of programs and technical writing, so that there's like a common thread. That's more of an idea. It's something it's something that'll take some time to develop. But definitely, I think we need to continue to work on our own pedagogy of writing.
Awesome. Some really cool ideas there. Thank you. So another question is, for you, with your experience these last 3 years, what has been the most difficult part of the performance task for your students in the pilot course, and how have you helped students address these issues?
Can I just pop in for a moment before we go on? I'm sorry to interrupt you, Eric. We cannot see your screen. So if you can just share your screen with a little green arrow on the right-hand side of the screen. I just wanted to point it out that we haven't been able to see your screen.
Yeah, I meant to do that, and I was just about to find something to share. So here's my screen, and I should show that rubric. When I was talking about the rubric, I should have had that up. So I wanted to show, in terms of the challenge. So you asked about what has been the greatest challenge, and how did I address it?
Exactly. Yeah.
There are many challenges, but definitely the first one that comes to mind is the performance task as a long period of unstructured class time. And for my students, in my context, long periods of unstructured time are difficult for the students to manage. They need to they need to have a lot of structure to keep themselves on task and to know what they need to get done each day. So what I did 2 years ago was something like this. I took the performance task description and I broke it up so that I had different parts of the task on a calendar. So students have a difficult time knowing what they should do on each day. So I made them a document that they were going to work in to put all of their writing and all of the pieces of their program that they had to do. And then in the document that I shared with them, I made this calendar. For each day, I put a link to either part of their document, like where it actually jumps down to the part of the document they should be working in, or a survey to give feedback to a peer, or a reflection where they would add a little journal entry on what they did that day. The performance task requires them to write about the development of their program. So at the same time that they're creating the project and documenting the project by analyzing an algorithm or analyzing an abstraction, they also have to be journaling about the ongoing development and the challenges that they faced. So I tried to create links to different things that they would need throughout, giving each other feedback. I facilitated through these links, documenting their ongoing process through the journal entries, going down to different parts of their document to write different parts of the prompts. There are several prompts, and they have to do some of them individually and some of them collaboratively. So building a kind of infrastructure like this helped it to feel like they were, in a lesson where there were certain outcomes or deliverables for each day, even though during these days I didn't help them at all. I wasn't able to give them feedback. I'm not able to tell them what to do. They come into class, they just start working, but it was all set up so that they could have a sense of what to do each day. I also kept track of their progress on a large board so that everybody could see everybody else's progress. Have a bit of public shaming to help them stay on task. It's really quite a lot of time that they need to be self-managing, and I think that structures like these can help. In the second year, I did something a little bit different, and I think that there are strengths and weaknesses to both. In the second year, we did sharing out of a whole folder of documents, so that instead of working in one massive master document with different links to different parts of the document, they had individual documents for the different parts. And this mirrors a kind of change in the task. This third year, the task is quite different in that there is no longer a separate collaborative portion. Now there's only the requirement that you do collaborate, but though you only create a single individual program, but that you have to do some form of collaboration, either getting feedback, or there's actually several models that are suggested. And I think so when I go into facilitating the task this year, the structures that I build will kind of reflect that new task, or that new structure, that they're going to be collaborating with somebody, but they don't have a shared deliverable anymore. So that'll change what the resources look like.
Great, thank you very much. So how do you assess the performance tasks and provide feedback to students?
So you can only provide feedback before the performance task starts. During the administration of the performance task, I don't provide feedback, but I do facilitate peer feedback. And a lot of what goes into the performance task is setting students up to be constructive collaborators for each other. And that's just a lot of practice of the use of the rubrics and the use of constructive language that's specific, relevant, and actionable. Those are the three key terms that we talk about every day when we're giving each other feedback. During the actual task, I don't give them feedback. I grade it myself based on the College Board rubrics. It has been the pilot year, so the College Board wasn't grading them itself. So I graded them using their rubrics as a way to give my students a summative assessment of the project. It also helped me to know where at least I thought they were. Now going into the first full year, the first live year of the performance task and of the CS Principles course, the create performance task will be the very last thing I do. I'll give it what I like to do is do the explore performance task in the middle of the year, and the create performance task, the programming performance task, at the end of the year, so we have the most amount of time to prepare for and develop our skills for the programming. After the programming task, that's a good question. I'm not actually sure what I'll do for giving them feedback. I think it'll feel like just like a big sigh of relief, something that we did, something that we're not gonna go back and change. I mean, it's really the end of the course. What I like to do instead of kind of going back to it and reviewing, I just like to end the year with something fun and a little different. My fun and different of choice is called Ear Sketch, which I'd love to tell you about.
Did I unmute? Sorry, I was muted and talking. Yeah, we'd love to hear that, and maybe we can include that in this question, which is recommendations that you have for prospective CSP teachers, specifically with respect to preparing students for the performance task, because that's a big area of concern for many teachers taking this class on next year.
So advice for preparing students for the performance task.
Exactly.
So the two things I'm going to package up two things that I've already said, but just like to put them really close together and concisely. You have to prepare them ahead of time for how to give each other feedback and how to manage their time. And you have to prepare them by building structures that they can use to complete their document, to get all their documents together. Because it can be, if you look at all these documents, I mean, there are 1, 2, 3, 4, 5, 6, 7, 8 pieces that are kind of, they were like individual pieces that they put together. And that includes, actually not listed here, is the video that they have to make. So there's a number of little pieces that needs to be kind of just like, when are you going to get it done, and what time frame are you going to get it done? When should you get what done by? So I think preparing them ahead of time and then giving them a structure for navigating that time are the two main things. Now, if you're asking for advice in general, if at some point, if you want, we could talk about how to put together a CSP course and what to look at if you're starting from scratch.
Thank you. I think that there are a lot of people taking the MOOC right now that would love to hear about how to structure a CSP course. Do you have any additional input for implementing an EP-CSP course?
So there are lots of curricula out there that are tailored to allow a teacher to take something out of a box and implement the curriculum. I've looked at a couple, and I've worked with some teachers who are using a bunch. After the first year, so I used something called The Beauty and Joy of Computing. It's a course that came out of the University of California, Berkeley, that they use for their Introduction to Computing for non-computing majors. And the BJC course is a great course that uses the Snap programming language. After I did 1 year using a different curriculum, and I had a year to wrap my mind around the curriculum framework and the performance tasks, I felt confident to start putting together my own course by pulling together lots of different resources from lots of places, and just being able to think about what was required and then to respond to my students. I'll say that the best thing about computer science principles is the flexibility that it offers teachers to respond to their classrooms. There are people who are going to implement this course all over the country, and they have students that are coming from rural backgrounds and urban backgrounds, and some of them will be very highly academically prepared students. They might be in a screened or specialized school. Some of them will be with low-skilled students. Some of them will be 9th graders, and some of them will be 12th graders. I think that variety really requires a teacher to pick and choose and to respond to their student. So it's partially the greatest challenge, and it's at the same time the greatest strength that you get that freedom. The freedom can be daunting, and I think my recommendation is to pick one of the established curricula and implement that for the first year. But then after a year, you're going to be very comfortable with the tasks and the framework, and you'll have seen your kids do it, and you'll start to put together additional resources along with the ones that you used in that first year. The curriculum that I'm working with and developing with right now, that I'm super passionate about, is a curriculum called Bootstrap, and I'm taking some of the principles in Bootstrap and trying to develop a course around those. So I think it really does offer a lot of opportunity for teachers to develop based on what they found really effective and what they found works for their students.
That's great. I'm a fan of Bootstrap as well. Eric, since you offered, one thing that we have found other teachers taking this MOOC are most concerned about is exactly what you touched on, which is how do you start an AP CSP course from scratch? And we would just love to hear your thoughts on that.
So I mean, the first thing I think for starting an AP CSP course is to use an established curriculum. What that really does is it gives you a lens into the curriculum framework. The curriculum framework is really quite an amazing document and something that's worth getting to know. But it does have 305 some odd knowledge objectives, and on a first reading, it's not something that you could directly plan a course off of, or I think that would be very challenging. And I mean, I've been doing it for 3 years now. I still find it challenging to digest and align against the curriculum framework. I have a massive spreadsheet that I built with lots of little drop-down lists so that I can do curriculum mapping and know that I have alignment. And it's not an easy thing to do. I would start with an established curriculum, and there are a couple of strong ones, and the College Board is going to recommend one. The College Board is also going to offer Summer Institute programs that I think that you should find a Summer Institute near you. The College Board's Summer Institutes are not going to be specific curriculum, they are going to go through a number of the learning objectives and talk about a variety of different approaches. So I think you might be able to implement the course off of just one of those summer institute workshops, but I think the curricula that are already kind of beginning to end built out would be the right choice for the first year, and then branch out from there. There's a lot of flexibility. Most of the curriculum actually are focused on the programming, and I think there's a lot more work to be done, and there's a lot of flexibility to develop in the objectives around the internet and the impact of computing, and exactly how much programming versus thinking about algorithms and thinking about abstraction outside of programming is really up to the teacher. I tend to do all of that in a programming language, which might not be the choice that other people make. Again, though, it really is about listening to that group of students that you're with, and thinking about how to impact them. The goal of computer science principles is to broaden participation in computer science. So when you're designing the course, the very first and foremost goal needs to be that students are engaged, and that they're thinking and learning about computing as a global phenomenon, that they see themselves in computing, and that they see the way that they can participate and affect the impact that computing has on their lives. As long as you've got that front and center and first and foremost, then you start by picking a curriculum, and then you start kind of listening to how that curriculum responds to your students, and then you'll put together a great course.
Thank you. Speaking of the students, how do you recruit for your CS Principles course?
Oh, I can't. Those questions aren't good for me. I have kind of a unique situation, which I'll describe briefly, but because of its being unique, it doesn't have a wide applicability. In my school, all students take 4 years of computer science, and we're so small that there's not a lot of programming flexibility that's based on student choice. Almost all programming happens based on graduation requirements and the requirements of other courses. So like they first have to get their English requirement and then their math requirement, and then they get programmed into their computer science course. The computer science teachers do make recommendations, although the first couple of years of our school, those recommendations haven't translated into student placement. There have just been too many other constraints that have affected the programming of students. But the ideal situation for us is that we would like, because in my school we want our students to also pass the AP Computer Science A exam, and we need them to pass that exam by their junior year, because we're trying to offer a career and technical education diploma, and we're trying to use that exam as our certifying exam. The CS Principles course is going to be our senior year portfolio course. And I've talked to, there's a number of schools where they do it in that order, and then another number of other schools that offer it as a prerequisite to AP Computer Science A. It's not supposed to be a prerequisite or vice versa. It's just that if schools are trying to offer both, they have to put one somewhere and the other somewhere. So that's not that situation doesn't have a lot to do with recruiting. Whenever I go to the meetings of the pilot teachers and the CS Principles Summit meetings, I just got back from one this weekend. The recruiting is a huge component. So I should speak about it, like, not from my own perspective, but from the perspective of the community. From the perspective of the community, recruitment is is really heavily on the shoulders of the teacher. And the best practices that I'm hearing is to really create a community in your classroom and to get the students to do the recruiting for you. Many people have observed that with young women bring other young women, and you want to encourage them in groups, so that they should try to join your class in groups and think about it as a social activity, and to heavily cultivate your students as your greatest promotional tool. A lot of teachers have talked about guidance counselors kind of bringing their own biases into the programming of students, even when you try to ask for a certain kind of student, or I think the right thing to do for computer science principles is say you don't want the most elite group of students. You want a wide range of students. You want students that are not typically programmed for computer science, if your school has other computer science, or students who are not in the most accelerated math program. But guidance counselors might still not choose to, they might bring their own biases and still give you only a certain kind of kid. And I think active advocacy, really, on the part of the teacher seems to be the best practices that other people are talking about.
Fantastic. Yeah, good job picking up on that without having to really do it, which is awesome too. What in your experience has been the most challenging part for you or moment while piloting the AP CS Principles course?
Most challenging moment. I mean,
or part.
So I've been talking about choosing a curriculum, and I think for your first year you're gonna need to choose some way to get the ball rolling. And there's a fair chance that you choose a curriculum and you get the ball rolling and it's just not working for the kids. In my case, I've spoken a lot about structure, and I believe really heavily in structure. I don't see a lot of success in my population when I leave things too open. I think to leave things really open, you do have to have a student population with a certain level of maturity and with like prior habits and stamina for problem solving and for kind of like staying with a problem long enough to work on a solution, to not give up right away. But if you're with a population with a general low self-efficacy that might not be accustomed at all to sitting with a problem or to being in an environment with freedom, I found that those curriculum were not very successful. So I've had a hard time that first year working in a curriculum that wasn't producing good results, that didn't have I wasn't getting very high level of engagement, and I wasn't getting a lot of my students weren't developing skills. So I mean it's the first year and you get through it and you learn from it and then you keep going and you think about what else is out there. So you need to be ready to listen to your students and to have it. It might not work, and it might be something that you have to change as you go. I did find a curriculum that year that I love and ended up using for the second half, called EarSketch, which is an online digital audio workstation that you write code in Python to generate music. It's an amazing tool, and EarSketch is a wonderful way to implement this course. EarSketch also has their own curriculum, and I would highly recommend it for somebody who wants to try it out. At the same time, EarSketch, as engaging as it is so engaging that it's really hard to move through different skills, right? You can have students work with one function for weeks, and there's just so many different possibilities with just that one function. But say you want them to learn a couple of other things, like you want them to also learn about for loops, and you also want them to learn about defining their own function to make a more complex song with multiple parts. They might not want to come with you because they're just having so much fun in that one thing. So actually, I've kind of gone to things that are a little less interesting, but that allow me to move through different concepts, and then to do something really engaging. So at the end, I kind of do a lot of structure during the year, and then kind of work my way into things that are more open-ended and have more creativity. But even the word creativity is something that I think is really interesting. The creativity that is talked about in the curriculum framework is one of having a creative process, but also of self-expression. So if you think about that as the creative process is sort of important, and it's a structure that gives students a way to approach problems even when they don't know the problem and they haven't seen it before. But the self-expression is something where they do need to have freedom to use computing like a paintbrush and to explore different parts of the world and of themselves. But when they're in a performance task, they have a certain amount of hours to generate an idea, to plan an implementation, to implement, and to document. And that's quite a lot to do in a short period of time, which without real skills and structures, students might flounder, given those constraints. I think balancing all of that was a challenging moment, especially in the first year, and will always be a challenge, but definitely one that you get much better at.
Thank you. I was actually at an AP Summit this weekend as well, and I heard a lot of talk about Air Sketch, so it's definitely something teachers should check out.
Were you in Boston?
I was.
No way.
Yeah.
We just missed each other.
So on the flip side, what has been the most rewarding aspect of piloting the CSP course?
Oh, the most rewarding. For me, I love curriculum design. So I've just loved the freedom to explore all these different things. I should probably say something about students, but I really have loved being able to explore all the different new tools. I'm really a fan of tools. I love exploring them, and this has just been such a great opportunity for that. But beyond that, I have to say that the community of practice, the CS Principles community of practice, is the most amazing group of teachers in the whole world. And to get to work with them, and if you take up this course, you'll join that community. It's really quite different. It's a movement. It's a really student-centered movement, and it's extremely rewarding to grow as a professional in this community.
I love that. That's awesome. So the option to teach AP CS Principles in any language frees up a lot of teachers to do a lot of interesting and innovative things, which you've touched on. The flexibility can be great. But it can also be really overwhelming in terms of choice and confusing in terms of how students will be evaluated against each other. How can teachers best prepare themselves to deal with these concerns?
To deal with all the concerns in the first year, you need to join a community of teachers that are implementing it with a specific curriculum. So join the Beauty and Joy of Computing teachers, or join the Project Lead the Way teachers, or join the Mobile CSP teachers, and you just use that curriculum. So if it's overwhelming that there's more than one to choose from, I don't think there's that many. We're talking about 3 or 4. If somebody has zero experience in programming, and this is going to be based on where where the teacher is coming from. So if we talk for the teacher who, I think in the case, this is what Jan Cuny was talking about at the summit last weekend. If we are talking about a teacher who maybe didn't even choose to teach this course, but somebody just told them, you're going to teach this next year. What should you teach? I think the most established curriculum, maybe the most established 3 curriculum, Mobile CSP, Beauty and Joy of Computing, or Project Lead the Way. Just randomly choose one of those 3. Join the groups, do the weekly hangouts, use the curriculum. In some cases, the students can work in a pretty self-paced environment. There are some that just have a MOOC that you can do with the kids online. I really love teaching, so courses that have like self-paced curriculum is not for me. I want the classroom to be together and for the classroom to reach a consensus. So I guess I don't have a really good answer for this question, because based on where the teacher's coming from, their prior experience, and the context under which they are coming into the course, there's not like a nice flow chart, although there should be, and it wouldn't be that hard to create. We should do that. So there should be a flow chart for teachers to just be like, this is who I am, which curriculum should I choose?
Okay.
The place to go is the AP Principles Community of Practice on the College Board website. Just go to the College Board website, search for CSP, and see what's there, what the College Board is promoting. And there's going to be a handful of tools and curriculum that they're going to put out there as endorsed by the College Board. And the most important thing I think about that is that you're going to join other teachers that are already using the same thing and have already generated a ton of resources and a ton of experience with that particular flavor of computer science principles. We'll work on the flowchart.
Sounds like a plan. I actually have an additional question. You've mentioned Bootstrap, but I didn't hear you mention it as one of the 3 that you would recommend teachers to go to right now for their first course. Can you kind of talk about Bootstrap a little bit?
I would love to talk about Bootstrap, and I'm so glad you asked. The only problem is I might talk about that for a really long time. It's what I'm really passionate about right now. Bootstrap is an Algebra 1 module for teaching algebra using computing. That's really what Bootstrap was. But Bootstrap is based on a college-level textbook called How to Design Programs. And the fundamental idea of Bootstrap and of how to design programs is to use a design principle when approaching a program. They use a programming language called Racket that looks different than other programming languages. Everything is wrapped in parentheses, and there's no semicolons or curly braces or commas. There's just spaces and parentheses. It's also a language where the function comes first. So instead of writing 2 plus 2, you write plus 2, 2. Some of those things make it a little bit different, but it's also very mathematical. And for me, because of my experience, I name Bootstrap the preeminent transition to computing course for a math teacher. And if you're coming from mathematics and you're at all trying to get into computing, you need to teach Bootstrap. The foundation is so strong. Bootstrap doesn't just teach programming, it teaches problem solving, which I think is really important. I don't think that students are very successful unless they have a way to approach problems. too many other approaches, like they take them through a number of programs and they build a lot of cool things, but then when they're on their own, they have no framework to approach something in a different context. But that is the fundamental and core idea of Bootstrap, is that you should have a framework for approaching problems in different contexts. So during last year and this year, I've been working with the Bootstrap team to develop the Bootstrap CSP. This year, we hope to pilot it with maybe 10 teachers in New York City. We'll do doing a beta working group and to put out a beta version on their website based on my lessons and my curriculum. That is not, it's definitely not the flashiest stuff. But students really design and build based on fundamental principles, real programs. And I think some of the beauty of what they produce is in the programs themselves, not so much in the output of the program. So that's like a very different idea than, say, something that uses App Inventor, where what you really are using is you're using the fact that they've built a phone app as the big motivator and as the big, like, look what I did. You know, I implemented something that's now on a mobile device. What I'm worried about is that could students do that again without the teacher? And what I really care about, what I most care about is skills. I want these students to have skills, and I believe in the engagement of skills. Students don't always need something flashy, and what I've experienced is that the engagement of like really neat graphics or video games or even music in the case of EarSketch, it can be too sweet and not really teach you anything except for like how to play in a kind of a small environment, or it wears off, where it's like, well, as soon as it got hard, I just kind of give up, and I can't get from the point where I was engaged to the point where I've done anything with rigor that required skills. When students have skills and they do something on their own, and they can tell that the teacher is not helping them, like that they really solved a problem on their own, I think that's super engaging, and I've seen students love that. Just solving a problem that didn't produce any graphic, just writing a function that solves a problem. We do teach a concept called recursion in Bootstrap, and we write some pretty simple functions, but students wrapping their mind around recursion and using it to solve problem statements, not by pattern matching, but by really using ideas. I've seen students leap out of their chairs, saying, "I get it," because of how engaging skills are. We're using sorry, I talked about Racket, and to kind of now jump to like a different topic, I wanted to go back to Racket because I was remembering that another thing that we're doing in Bootstrap now and in the Bootstrap CSP is transitioning from Racket to a new language that the Bootstrap team developed. It's actually developed at Brown University, called Pyret, Pyret, and it's at pyret.org, and they have an online coding environment called code.pyret.org. Pyret and Racket have the same semantics, meaning the statements in the language mean the same thing, but the syntax, what it looks like, is very different. Pyret has syntax that looks just like Python, so that's why they call it Pyret, Pyret. When you go between two different languages in the same course that have the same semantics, it's another it's another mechanism that helps break students out of this idea that I called pattern matching. If we want to develop higher order thinking, students really being able to solve problems, we have to get them outside of the context in which they learned the skill. And one of the things that they do is they learn certain patterns for writing programs. This happens a lot in the visual languages like Scratch and Snap and Alice and App Inventor. The blocks snap together and they look a certain way. And students can continue to snap the blocks together to make that same shape. And they sort of understand the shape and remember the shape, but have very little skills for debugging or for investigating. And if something changes, they don't really know how to track the changes or to adjust to them. Switching between these two languages and using a strong pedagogy of design and problem solving breaks students out of pattern matching behavior and kind of raises them up to a more conceptual plane, thinking about like what type of data is going in, what type of data is coming out, how would I describe the computation here, what would be concrete examples of the computation, can I develop a computation based on those concrete examples, and then use the concrete examples as tests to do any necessary debugging and to adapt to any changes in the situation. So that's why I love Bootstrap, and hopefully after this year we'll have a beta version to offer, and then we'll have something more substantial to offer in a year from now.
Thank you so much, Eric. You've answered all of our questions, and I want to thank you so much for joining us tonight. It's been a real pleasure chatting with you, and definitely a wealth of knowledge to offer those of us taking a look at anybody who wants to search for this video on YouTube.
Thank you all. It was a pleasure to speak with you tonight. This is something I've been working closely on and that I'm so passionate about. So we're getting ready for the launch of CS Principles and to get a whole another group of teachers on board, and it's really exciting work. Thank you.